Welcome back. It's been a while, so long I've chopped off my sleeves because it's now officially summer and I won't hear otherwise. So we're going to continue on with integration, and today we're going to be having a look at integration by substitution. A neat little trick that works sometimes and sometimes a little unintuitive as to how it works, so let's break it down. So imagine I've got an integral here, the integral of x times by the square root of 2x plus 5. Now, if this was a derivative, if we're trying to find a derivative of this thing, we'd be thinking product rule and then a chain rule in there as well. But there's no such thing as a product rule for integration when we have two functions that are multiplied by one another. But quite often, when we do have two functions that are multiplied by each other, it's useful to use this idea of substitution. So what is substitution? Well, substitution is replacing a really annoying looking function with a different argument, a different variable, so no longer x. So our whole goal is to try and rewrite this in a way that eliminates all the x's. And there are three x's here, there's one here, and there's also the dx as well, which will come into play. So, as is generally true with our substitutions, we're going to use the letter u as our substitution. Now, in this case, what I'm going to do is I'm going to tell us that u is going to be equal to this thing here. I'm going to set u equal to 2x plus 5, okay? Now, if you're in the UK and you're doing A-levels, most of the time when you have to use substitution, you will be told what the substitution is. But I'm going to go into a bit of detail as to how we would come up with it if we're not told. So, first of all, just take my word for this and you'll see why this is so important in a second. Why it has to be this. And why it's not, very keyly, as you might have assumed, the square root of this. So we're keeping the square root here. So let's rewrite this integral. So x times, well, that whole thing is u to the half dx. Now, looking at this, I've only solved one of my problems. Because remember, I did mention that we need to get rid of all of our x's, because this here is useless, okay? This here is suddenly just integrating x with maybe a constant next to it. I mean, if I just saw this, that's what I would probably assume. So it's not very useful. So what I need to do is I need to start replacing these. The first thing I'm going to replace is this dx. Now, don't fall into a bad habit of just rubbing out that x and replacing it with a u. We can't do that, okay? We do need to justify the replacement of this dx, and we can't just throw a du in there. The way we're going to do that is going to look at our original substitution, and we're going to get a dx from here. So I'm going to find du by dx. And luckily, in this case, that is just going to be 2. Yeah? The derivative of 2x plus 5 is just 2. So, if that's the case, then I can replace, or I can cross multiply and get that du is equal to 2 times dx, and therefore du divided by 2 is equal to dx. And now I've got something with a du in it I can replace for my dx. So to save space, let me rub that out and replace my dx with my du divided by 2. All well and good so far, but I've got another problem. I've still got this x in here now. Now in this case, in this very simple example to start with, is actually quite simple. All we need to do is rearrange this equation here for x, which shouldn't be too difficult to do. I can just minus a 5, divide by a 2, and I get an x. And I can chuck that u minus 5 over 2 into here where that x is going to be, and I get u minus 5 over 2 times u to the half times du over 2. Now this does look like a bit of a mess, right? But I can expand this out into something that's very polynomial and very nice. Very polynomial, I don't know if that's... Doesn't matter, I say things. So, let's expand this. So, u to the half times by u, and what I'm actually going to do, actually no, let's stick with that for now. U to the half times by u is u to the 3 over 2, minus 5u to the half, that's all divided by 2, and it's times by du all divided by 2 as well. So that 2 I'm just going to bring down on the bottom here, multiply there, and I get the 4. And at this point, we look at something that's actually quite nice. I can bring my 4 outside, or my 1 over 4 outside, and I just have the integral of u to the 3 over 2 minus 5u to the half du. And this integral is very nice to solve. Polynomial power rule. That is just going to be 1/4 times by, add 1 to the power, 3 over 2 plus 1 is 5 over 2, divide by that power, so I get 2 over 5 u to the 5 over 2, minus, add 1 to that is 3 over 2, so divide by that is going to be 2 over 3 times by 5, which is 10 over 3 u to the 3 over 2. And that there is our final answer. Except it's not, because our answer is in terms of u, but it needs to be in terms of x. So I would simply go back into this, and I'm going to do it somewhere in the middle over here. I would go back into this, and I would replace, let's make a bit of room, replace all my u's with that equation there. So it's 1 over 4 times 2 over 5 times u, which is 2x plus 5 to the 5 over 2 minus 10 over 3, 2x plus 5 to the power of 3 over 2. Simplify at will. Plus c, always plus c. Didn't forget that at all just before I rubbed it out. Thank God I didn't rub it out. Plus c, always remember plus c. I never forget it, neither should you. Don't forget plus c. I mean, it's ridiculous. Okay, let's take a look at a much harder example where our choice of substitution immediately doesn't look very obvious. Maybe it does. If it does, well done. But in this case, we have a problem. We have 3 functions, one of which is cubed and all of which have got trig in them, which is usually not a recipe for success. But by using a certain substitution, we would actually be able to cancel some terms early, and this is a very, very handy thing to note about substitution. Wasn't present in the previous example, but in this one, it very much is. So the substitution I'm going to use, quite similar to the last one actually, is the function that is within the indice. So my substitution is going to be u is equal to 1 plus sine of x. Not 1 plus sine of x cubed. We never want to have that indice within our substitution, or we usually don't at least. But in this case, completely lost my train of thought. Can't be bothered to write it. 1 plus sine of x is going to be our choice. Yeah, we don't want the indice in there. Completely, I haven't recorded a video in 2 weeks, can you tell? So, that's going to be my choice substitution. I'm going to leave the cubed out because when I differentiate it in a minute, I don't want to mess with that indice. That's what I've been trying to say this whole time. So, as before, I'm going to kind of want to take a note of what the derivative here is going to be, because I'm going to want to replace that dx with something. So, well, derivative of 1, well, that's just 0. And the derivative of sine is cos. So du by dx is cos x, and if I rearrange that for dx, as I know I'm going to want to, I will get du over cos of x. Okay, now let's start replacing. So I have cos x here. Can't do anything with that at the minute. I've got sine x here. Can't do anything with that at the minute. But then I've got 1 plus sine x, which is u cubed, and then dx can be replaced with du divided by cos x. So I'm going to throw the division on the entire thing. And this is where something quite nice happens. And this is something that you would expect to see when doing substitution, which is this annoying cos has now been cancelled. And this is where choosing what the substitution is very, very important. We always want to choose a substitution that in some way or another is going to eliminate all of the x terms. Now this choice of 1 plus sine x very neatly does that because of the fact that when I differentiate it, I get a divisor by cos, which then, when I divide the whole thing by cos, says bye-bye to the cos. This sine, which is the only thing left, well, that's easy. Sine x is just u minus 1. I can just move that 1 to the other side. So my final integral is going to be sine of x, which is u minus 1, times by u cubed du. Look at that. Very nice. Expand that bracket, and I get u to the 4 minus u cubed du. We can all solve that in our heads. That is going to be u to the 5. Don't want the integral sign there. Oops. Solve it in your head, it's easy. There we go. U to the 5 over 5 minus u to the 4 over 4 plus c. Never forget the plus c. Never have, never will. Always remember the plus c. U to the 5 over 5 minus u to the 4 over 4 plus c. Very nice. And then, of course, just to finish it off, we want to replace my u's with my x's. If this is an exam, I'm never going to get the mark if I leave it in terms of u, because the question has it in terms of x. So I need to flip it back and just replace all my u's with 1 plus sine x. 1 plus sine x to the 5 over 5 minus 1 plus sine x to the 4 over 4 plus c, the constant.